Hello students, welcome back to a discussion on Newton's laws of motion. I'm Harsh Kapil. So far we have discussed many things about Newton's laws of motion, like how to understand multiple forces acting on a body, how to find out the system where you need to find out the multiple terms asked in the question, how to draw the free body diagram, and after that how to apply the three laws of motion, Newton's laws of motion. So we have understood these stuff so far. Now let's take the discussion further. Right, now these are certain institutional information where you can always get in touch with me for personal guidance program. We have seen the basics. What are the forces? Okay, what is a free body diagram? Okay, what is a Newton first law, second law, third law? What is inertial frame? You need to remember this, that Newton's laws are applicable only in case when it is an inertial frame. We will also see when this is not an inertial frame, that means if the frame itself is moving with some acceleration or a variable velocity, then how to apply the Newton's laws of motion. We will see this in pseudo forces. Okay, we have seen multiple examples to understand free body diagram. Okay, only three things that you have to remember in this chapter while solving the problems related to Newton's laws of motion is first to understand and find out the system. Okay, after that you have to understand the forces acting on that particular system or the body. After that, the third step is to draw the simple diagram with body and the forces, or free body diagram with dot and the arrows. Dot means the body and the arrows means the forces pointing in the respective directions. Okay, this simplifies your problem, and after that you can apply the Newton's laws of motion, okay, as per the discussion that we have already done in the last two discussion of this chapter. Okay, now we have seen these two examples. Okay, now see more example, because in this chapter you have to do more and more questions, because only three laws are there. Free body diagram concept is simple, you only need to apply them in the multiple questions. Once you are done with at least 20 questions, then you will be able to easily solve even the hard problems, like when we will apply the pseudo forces or we will apply the friction. Those will be easy for you. Okay, now today we will bring some more concept here, like a tension. What is a tension? We know all that. Tension works in rope, string, or chain. Okay, if in case we assume, for our simple understanding here, that the rope or the chain itself is massless, okay, having no its own mass. Okay, then we will be applying the throughout in the rope a uniform tension, to say T here. Okay, even if you cut the rope into pieces, the tension throughout the rope or in the pieces itself will be same. Okay, so the tension throughout the rope or chain or string will be same throughout its length. That is first thing. If in case the chain or rope or string has its own mass, then we will solve that problem also. How do we simplify that problem into the normal Newton's laws of motions problem? Okay, but so far tension will remain throughout its length same. That is what we have to assume. Okay, now you can see here, this man is pulling the box, okay, with a tension T. So this is a pulling force. Okay, this chain, rope, string, these are all the pulling force. This does not have sufficient stiffness inside so that it can push a body. Okay, so this is our assumption. Why do we call it pulling force? Because it cannot push, it can only pull. Okay, it has that much strength that it can pull. Okay. Now we will, in this case itself, we can see the tension is in that particular direction. Then we can draw the free body diagram of the block or the man, if in case required in the question, and we can so apply the Newton's laws of motion. Now in this case, in the second example, there is a block of mass m that is connected with two strings. Okay, one is in the upper direction in the roof and one is in the left direction with the wall. Okay, the upper string is having a tension T1 and the left string is having tension T2. The upper string is making theta angle with the x-axis as shown. Okay, how do we analyze this? Very simple. We have to first find out the system. What is that? In this case, that is the block. Okay, second thing, we will find out the forces. What are those? Tension, correct, blocks its own mass, that is m, and its weight, that is working in the downward direction. Okay, mg, tension T2. These are the only three forces acting on the block, right? Any other force? No. Okay, then we will draw the free body diagram, third step. This is the free body diagram. Okay, block is dot, or you can even draw the block also, but that figure must be very simple. Now T1, T2 mass. Block is having any movement? Okay, no. Then I write the Newton's second law. What is that? F is equal to ma. Is there any acceleration? Zero. Then F is equal to net overall forces will be zero. Okay, then what is the net force acting on the block in the x direction? Okay, in the x direction, balance the forces, apply the Newton's law. In the y direction, apply the Newton's second law. Okay, x direction, net forces T1 cos theta minus T2 is equal to ma. A is 0, so T1 cos theta minus T2 is equal to 0. First equation. In the y direction, T1 sin theta minus mg is equal to 0, right? These will be the only two equations that we will be able to draw from the Newton's law. Okay, clear so far? This makes the problem simple. Okay, now whatever things those are asked, T1, T2, we will be able to solve by these two equations. Clear? Take the third example here, this one. The block M is connected with two strings making an angle alpha and beta with the horizontal in that direction shown like this. Okay, now draw the free body diagram like this. Mg force downward, T1, T2 like this. Now what will you do? Draw, apply the Newton's law of the motion in the x direction and Newton's law of motion in the y direction. F is equal to ma. Balance it, balance the forces. Acceleration 0, so F overall applicable forces on the block in the x and y direction. Okay, their total value will be 0. Okay, this is in the x direction, T1 cos alpha minus T2 cos beta will be 0. In the y direction, T1 sin alpha plus T2 sin beta minus mg is equal to 0. Simple. F is equal to ma. F is total or the net force acting on the body. So far it's clear, right? So we will be able to draw the free body diagram and apply the Newton's law of motion. Clear? So far we have assumed that there is, in these example, there is no motion in the body. We will bring the motion also. Okay. Now take the example of a pulley. Okay. You must have seen the pulley, okay, in the well. Okay, when we draw the bucket full of water, try to pull it, that is a pulley. In multiple factories, okay, there is a lot of application of the pulleys so that our efforts to pull up heavy weights is reduced. That is pulley. Okay, Now there are certain assumption here in this case. As you can see here, this is your pulley. Okay, this is a big pulley. First of all, there are two blocks. Okay, those are hanging around it, M1 and M2 with one single string. Okay, assumption one is that string does not have any mass, as we have assumed already in the previous slide. Okay, string is massless. Okay, now tension between point A and C will be uniform, as we have seen earlier also, that the tension throughout the length of the rope or the string will be same. So between A and C point, due to mass m2 or weight of m2 m2g, there would be a uniform tension, to say here T2. Due to mass m1 and its weight m1g, the tension between B and D will be uniform, correct? Assume here that is T1. Okay, so between A and C and B and D there is a uniform tension, but that will be different if there is a big pulley having some mass. Okay, now if we assume further that pulley is light or massless, that will you will be observing in multiple numerical example from S.C. Verma or Irodov or Resnick Halliday, that they particularly write that mass of the pulley is light or it's massless. When they say that the pulley is light or massless, then this is the case. Tension on the entire length of the rope between the blocks M1 and M2 will be same. Okay, remember this. When you are solving the problem, if it is mentioned that the pulley is light or massless, then between these two blocks M1 and M2, or whatever blocks those are there, the entire length has the uniform tension, right? This is what is you have to assume. Now take this example here. This is a wedge having an angle theta with the x-axis, and one mass is connected here, and through a pulley, through a rope, it is connected with mass m2. Okay, now assuming here once again it will be written in the problems that the pulley is massless or light, correct? Then the tension throughout the length of the rope between m1 and m2 will be same, and we will assume here that is T. Okay, now what is our job if in case there is no motion in the system at all? Okay, neither the wedge or this inclined wedge is moving, nor the m1 or m2 is having any motion. Okay, this is our assumption in this case. We have not brought any motion yet in the any of the problem yet. We will bring it later. So what we will do, we will first draw free body diagram. Okay, see here, for both the blocks we will draw the free body diagram. This is for the m1, this one big one. What will be the forces? Its own weight in the downward direction always, m1g, this one. Normal reaction perpendicular to the surface, n. Okay, tension we have seen here, this one. Okay, is there any other force? No. Okay, then draw it properly like this, n t m1g angle theta. Now in our discussion in projectile motion, if you recall that we had to choose the desired axis, x and y axis, so then we can divide the velocity in projectile motion. Now in this case also we will be choosing, in this chapter also we will be choosing our axes in a way so that we can divide the forces so that we can reach to the desired result. Okay, now in this case we will be dividing our axis, choosing our axis, x-axis, in the inclined plane's direction, and the y-axis perpendicular to it always. Okay, this will make our problem easier. Okay, Now apply the Newton's second law. F is equal to ma. There is no acceleration, so overall net forces will be 0. Okay. In the y direction, n divided the m1g in the y direction. So n minus m1g cos theta is equal to 0. Okay. Let me show it properly. In this direction, we are applying the Newton's law. N in the upward direction plus positive y-axis direction, divide the m1g theta here, this will also become theta. So this is the negative y direction. So what will become the equation? F is equal to ma, a is equal to 0, the F is equal to 0, net forces will be 0. So n minus m1g cos theta will be 0. Now apply the equation in the x-axis. What are the forces in the positive x direction? T. Negative x direction, m1g sine theta. So T minus m1g sine theta will be 0. Correct? You got that equation. You can find out the tension. Okay? And the normal force. Clear here? Now, draw the free body diagram of the M2. That is very simple. There are only two forces. One is a T in the upward direction, tension, and its own weight in the downward direction. The equation, and the block is having no movement or acceleration. So the equation will become T minus M2G is equal to 0. Net forces will be 0. Correct? Now you have these equations. You can solve as per the question. Correct? If you have any doubt, you can write in the comment box. Okay, we will discuss rest in the next lecture. Thank you.